अस्सलाम वालेकुम एवरीवन, क्या हाल चाल हैं आप लोगों के? Anybody here from Bloomfield? Bloomfield, I think, is a school in Bangladesh, if I remember correctly. Walaikum salam, IGCSE May June. Hello. IGCSE के स्ट्रीम्स ख़त्म नहीं IGCSE के होंगे अभी और होंगे, डोंट वरी. अभी एड मैथ्स का डिफरेंशिएशन करके I'm going to take a break for add maths and then I will do IGCSE Math. I'm resuming inshallah most likely this week with transformation. Transformation की काफ़ी demand है, so I'll resume with that. Yeah, exactly. वैसे for add maths you guys have time. For math you don't have a lot of time. Yes. You have your add math P2 tomorrow. All right. Good luck to you. So what do you predict the grade threshold for February, March 2025? I've gotten a hold of the paper, but I haven't seen it in detail, so I really can't say anything. Paper 2 तो मुझे relatively ऐसे आसान लगा था. I just skimmed through it, so I really can't say. I really can't get down to the specifics, but let's see. Anyway, so we had done equation of tangent and we had done equation of normal. Okay, so let's see what it is that we are supposed to do today. So we are supposed to do stationary / maximum / minimum point, and if time allows we will also do rates of change. Nature तो साथ साथ हो जाएगा. I think target करते हैं to do at least 1, 2, 3. Let's target this. Okay. Sir, can't you leak the O-level paper? The thing is, you might celebrate the leak for a while, but it's a short-lived happiness, because then your life is going to be all the more miserable when you have to sit for the paper again. So all these leaks and paper getting cancelled, ये सब थोड़ी देर की खुशियाँ होती हैं कि वो पेपर कैंसिल हो गया या एक पेपर के मार्क्स दूसरे पेपर में भी मिल जाएंगे. पेपर नहीं देना पड़ा, but then students always regret it. You know, A-level students are still regretting right now because their AS paper got cancelled, and then, you know, they had to give retake in October, November, and then, you know, A2 got compromised. So that's not really a good situation to be in. Okay, sir, functions जब करवाएंगे तो ln और e के ग्राफ्स एक मैं सेपरेट स्ट्रीम में कवर कर लूँगा. वो बहुत छोटी सी चीज़ है, डोंट वरी अबाउट इट. Sir, my syllabus is not completed for O-level maths. What's the tip to complete my syllabus? Well, the tip to complete the syllabus is to complete the syllabus. That's it. That's the best tip that I can give you. But alongside, what I will say is keep solving yearly past papers. That's important. Sir, will your past paper session be held on Zoom and it will last until the exams begin? No, the past paper session will go till the exams. Okay, the past paper session will go until exams, and it's starting from the first week of April, and you guys can register for it directly from the website. Okay, so, and you can register from anywhere. If there's a clash, you cannot attend the live class, then you will get a recording of it, which you can watch later. So there will be past paper sessions, and alongside there will be question answer session as well. Okay. So anyway, I am going to now solve. Let me adjust the camera a little. I'm going to now cover stationary / maximum / minimum point. Okay. So let's begin. Now, what exactly do we mean by stationary / maximum / minimum point? इसका मतलब क्या है? This is what it means. A curve has a turning point, okay, and that turning point is also known as stationary point. Okay, a curve has a turning point, and that turning point is also known as stationary point. Achha, ab if we have the curve in front of us, we can tell whether it's a maximum point or whether it's a minimum point, right? So for example, if we have this curve in front of us, it's easy for us to tell whether it's a maximum or a minimum point. No big deal. Anybody can tell whether it's a maximum or a minimum point, okay? But what if you don't have the curve in front of you? What if you have the equation, and now with the help of the equation, you want to decide whether it's a maximum point or a minimum point? What do you do in that case? In that case, you will basically use something known as finding the nature of the stationary point. That's what you're going to do, okay? But the question is, how do we find out the turning point through differentiation? Now, we saw earlier that the primary purpose of differentiation is to find gradient. Okay, the primary purpose of differentiation is to find gradient. Now, if you look at this curve, you can see that this curve has two stationary points, one right here and the other right here. Now, if I were to, let's say, draw a tangent at each of these stationary points, the tangent would be a horizontal line. Okay, so if I were to draw a tangent on each of these turning points or stationary point, they both mean the same thing, okay? We would get a horizontal line. Now, what does that mean? What does getting a horizontal line mean? That means this curve at these values of x, okay, at these specific points will have what? Will have gradient 0. Okay, why? Because a horizontal line, we know if you take the gradient of a horizontal line, तो उसका dy by dx क्या होता है? उसका dy by dx 0 होता है. So this horizontal line will also have gradient 0. Okay, and there's the corresponding y value, so we're going to call this y1, and the corresponding y coordinate here, we're going to call this y2. Okay. Now, let's make some notes. So the idea here is that tangent at any turning point, the tangent at any turning point will be horizontal. So it doesn't matter whether it's maximum or minimum, but if you were to make a tangent, it would be a horizontal line. Now, if the tangent is a horizontal line, therefore dy by dx will be equal to what? Dy by dx will be equal to 0 at every turning point. Okay, dy by dx will be equal to 0 at every turning point. बेटा माइक सही है, आप अपने वॉल्यूम तेज कर लें, ठीक है? I think that will solve the problem. All right. So now the question is how to find the coordinates of the stationary point and determine its nature. Okay, is anybody else facing an issue with the mic? If yes, please let me know. I don't think there's an issue. I can see it's working fine. चलो मैं आपके कहने से वॉल्यूम थोड़ी और बढ़ा लेता हूँ. So I'm afraid the problem is at your end. So how to find the coordinates of the stationary point and determine its nature. Okay, so we're going to look into how to find out the coordinates of the stationary point and determine its nature. Here it is. Now first we're going to write down the steps, okay, and then we will apply these steps to an example question as well. ठीक है, पहले हम कुछ steps लिख लेते हैं और फिर हम उसको एक example question पे apply करके भी देख लेंगे. अच्छा, I forgot to mention, those of you who are watching and you haven't liked the stream, please do so. And also if you haven't subscribed to the channel, please do that also. I will appreciate it. Okay. Now, here is step 1. How to find the coordinates of the stationary point and determine its nature. So step 1 is that you differentiate. Step 1 is that you differentiate the equation of the curve. Okay, and when you differentiate the equation of the curve, what do? You do it to find dy by dx. As in, what do you get? You get dy by dx. Okay, so that's the first step. All right. Then comes step 2. Step 2 is that you equate dy by dx to 0. Okay, so once you've differentiated, you equate dy by dx to 0. Okay, and dy by dx will be in terms of x. So what are you going to solve it for? You will solve for the x coordinate or perhaps coordinates of turning point. Okay, because there can be one, there can be more than one, so that's what you're going to solve for. Okay, meaning that you may get x1 or x2. x1 and slash or x2. All right, then comes step 3. And what's step 3? Now remember, stationary point means that you want the x coordinate as well as the y coordinate. Okay, stationary point, remember, point बनता है दो coordinates का, एक x coordinate का और एक y coordinate का. So if you want the stationary point, you want to find out the x coordinate and you want to find out the y coordinate as well. So can you do a separate stream covering different questions where it says show that x or y varies? But let's take things step by step. Okay, I have no idea what you mean by that, by the way, but I'm sure you will see a question which covers that. Okay. Then comes step 2. So what do you do when you have the x coordinate of a point on the curve and you want to find out the corresponding y coordinate? So you plug in the x coordinates in the equation of the curve to find out the corresponding y coordinate. So you plug in the x coordinates of the equation, plug in the x coordinates of the turning point or the stationary point in the equation of the curve to find corresponding y coordinates. Okay, now let's solve an example question and see what's what. So here is a question that I'm going to solve, and it's straight away a past paper question. Okay, so let's go over the steps one more time. We differentiate the equation of the curve, we set it equal to 0, and we then solve for the value of x. Once you have the x coordinate, you can plug in these x coordinates back into the equation of the curve so that you can find out the y coordinate. And we only do that if the question says. Sometimes you will notice, like the question that I'm about to solve, here the question is only concerned with the x coordinate of each of the stationary points. That means you don't want the y coordinates. Okay? So let's solve this question. Let's see what's what. Okay, आज I think stream थोड़ी lag कर रही है. Something wrong with the internet maybe. Khair, anyway, so let's solve this question. So we have a fraction, so that means we'll have to use what? We'll have to use quotient rule. Okay, so this is what it looks like. Y is equals to u upon v. What's u is equal to? U is equals to 2x. What's u prime equal to? U prime is equals to 2. What's v is equals to? V is equals to x squared plus 9. So that means what's v prime going to be equal to? V prime is going to be equal to 2x. Okay. So what does quotient rule say? Quotient rule says vu prime minus uv prime. Okay, vu prime minus uv prime upon v square. So vu prime means 2 times x squared plus 9. Okay. Minus 2x times 2x, so that's going to be 4x squared upon x squared plus 9, the whole thing square equals to 0. Okay. vu prime minus, yeah, that's correct. Okay. So just a minute. Let me see if I can fix the lag. Let me see if I'm connected to the correct internet. Yeah, I am. Okay, so hopefully, let's hope कि थोड़ी देर बाद खुद ही सही हो जाए. Now, sir, the previous mic volume was good. There are now noises of your surrounding. Acha? Okay, so I'll lessen it up. There you go. Now, we equate it to 0, and as soon as you cross multiply, the denominator disappears. So you don't have to simplify, just cross multiply and start solving. So what do you have? You have 2x squared plus 18 minus 4x squared equals to 0. Okay? So let's solve this further. We have minus 2x squared plus 18 equals to 0, which means minus 2x squared equals to minus 18. Now minus minus cancel. X squared is equals to 9, and notice the question says find the x coordinate of each of the stationary points. What does that mean? Points mean that you're likely to get more than one. And what happens when you take the square root of 9? You get plus and minus 3. Okay, so these are the two x coordinates of the stationary points. All right, so pretty straightforward. Now, what about the nature? What about the nature? Now, when we say nature का मतलब होता है whether it's maximum or minimum. Now, what we do for nature is that we find out something known as the double derivative. Okay, what do we do for nature? We find out something known as the double derivative. Acha, ab iske liye, in order to explain this, what I'm going to do is I'm just going to show you guys a table. Okay, it's more like a flow chart. And with the help of the flow chart, you can determine the nature of the turning point. Okay, so just a minute. I will copy paste that table here and walk you guys through it. And by the way, I don't know if I mentioned this, but you guys can download all my notes. They're available on the website. Okay, you can download all the notes. They're all available on the website. Okay, so here is how you can determine the nature of the turning point. Okay, now I'll explain this step by step. Nothing to worry about. Our trigonometric derivative we will cover inshallah when we are doing part 2 of differentiation. Okay, so when we're doing part 2, that is when we learn how to differentiate trigonometric, logarithmic, exponential function. This PDF I've already uploaded in the, you'll find a link in the description where I've already shared this PDF. Okay, so this is how you find out the nature. Okay, you double derivative. So this is a continuation of step 3. Okay, there is a link in description, you can get it from there. Now, what's step 4? Step 4 is that we find d square y upon dx square, which is what we call double derivative, and you do that by differentiating dy by dx. So how do you get dy by dx? You get dy by dx by differentiating the equation of the curve. How do you get the double derivative? You get the double derivative by differentiating dy by dx. Okay? Now, when you get the double derivative, there are two possibilities. One possibility is that it's a constant, meaning that it's a value. If it's positive, that means it's minimum. If it's negative, that means it's maximum. Earlier, somebody asked, what do we mean by nature? Nature, so every turning point is either minimum in nature or maximum in nature. Okay, so this is a minimum turning point, this is a maximum turning point. So once you get the double derivative, if it's a constant, see whether it's positive or negative. If it's positive, it's minimum. If it's negative, it's maximum. The other possibility is when you find out the double derivative, you get it in terms of x. Now, if it's in terms of x, what do? You plug in the x coordinates of the turning point. As soon as you plug in the x coordinate of the turning point, you will get a constant, and then once again see whether it's positive or negative. If it's positive, that means it is minimum. If it's negative, that means it's maximum. Okay, but you can find some other stream. Okay, obviously I'm not gonna change my plan for you. You can wait before CIs, inshallah I will cover it. Okay, when will you upload the last episode of M1? So I'm gonna do kinematics from scratch inshallah very soon, so don't worry about it. Okay, all right, so here is a past paper question which I am going to solve, and here it is. Now here, not only do we have to find out, just a minute. Okay, so here not only do we have to find out dy by dx, but we also have to find out the double derivative, and then we have to find out the nature of this stationary value as well. Okay, so how many marks? It's a 7-mark question, so just make sure that you don't skip any steps. So first part is that we have to find out dy by dx and d square y upon dx square. Now what I would like to do is, don't just straight away start differentiating. Write it in a way so that it's easy for you to differentiate. What I like to call this is making it differentiation ready. Okay, so I'm just going to make it differentiation ready, meaning I'm going to write it as a power function. Now we can differentiate it. So if I differentiate it, this is what happens. Power gets multiplied. So it's going to be 1 upon 2x. Half minus 1, that's going to be minus half. 9 into minus half, that's going to be minus 9 upon 2. X raised to the power minus half minus 1, that's minus 3 upon 2. Okay, so here we have dy by dx. Now you can leave it as it is. If you want, you can write it nicely, but this is good enough. Okay, now let's find out the double derivative. So I'm going to copy paste this. Let's write this here. Now let's differentiate this once again. So if I differentiate this again, this is what we get. D square y upon dx square. Now minus half multiplied by half, that's going to be minus 1 upon 4. X raised to the power minus half minus 1, that's going to be minus 3 upon 2. Now be careful over here. First of all, minus minus will become plus. Okay. 9 upon 2 into 3 upon 2, so that's going to be 27 upon 4. X raised to the power minus 3 upon 2 minus 1, that's going to be minus 5 upon 2. Okay, so we have the double derivative as well. We have dy by dx. Let's put this on the side. And let's focus on part 2. Part 2 says, show that the curve has a stationary value when x equals to 9. Now, how will I do that? How will I show that the curve has a stationary value when x equals to 9? So we'll take dy by dx and equate that to 0. So let's take dy by dx, set it equal to 0, and let's see what happens. So here's dy by dx. Let's equate this to 0, and then let's solve. Now, let's try and avoid using a calculator over here. Okay, let's try and avoid using a calculator over here. Why? So that we can practice. Because I think questions like these you will get in the non-calculator paper. So let's practice that. Ab there are two ways to go about it. Either you can solve for the value of x and show that it's equal to 9. The smarter way, if a question like this comes in paper 1, where you cannot use a calculator, there's a smarter way as well. What's the smarter way? Anyone would like to tell me what the smarter way is? The smarter way would be that you plug in the value of x and show that its dy by dx is equal to 0. So 2 times x cube inside the square root. So I've used rules of indices to make it positive. Now I'm going to plug in the value of x, which is equal to 9. Okay, remember, no calculator. Try not to use a calculator. So 2 times square root of 9, we'll figure that out in the next step, minus 9 upon 2. Inside the square root, we'll have 9 cube. And don't forget to take the square root of it, okay? So we're taking square root of 9 cube. And we have to show that it's equal to 0. So the square root of 9 is 3. 3 times 2 is 6. So we have 1 upon 6. Now let's see what this gives us. Square root of 9 is 2. Square root of 9 is 3. 3 cube is 27. So we have 9 over 2 times 27. Now let's simplify this. 9 ones are 9. 9 threes are 27. So 3 times 2 is 6 again. So we have 1 upon 6 minus 1 upon 6, which is equal to 0. So there you go. Since dy by dx is equal to 0 at x equals to 9, that means there is a stationary point. Therefore, it's a stationary point. Okay, so I'll give you a quick summary. So we got dy by dx, and we had to show that the curve has a stationary value when x equals to 9. Now, like I said, there are two ways to go about it. You can solve this equation for the value of x, or you can be smart. You can plug in the value of x into the equation and show that it is in fact equal to 0. Okay, so this is 2, and I'm using rules of indices over here. When the power becomes, remember, in order to make the power positive, you have to take the reciprocal. Okay, so we take the reciprocal, power becomes positive, and then we solve for the value of x. This is what we end up with. Okay, so that's part 2. Now let's do part 3. Let's see what part 3 says. Part 3 says, find the nature of this stationary value. So how do we find out the nature of the stationary value? We have the double derivative for that, d square y upon dx square. And what's that equal to? That's equal to this right here. Nature nikalne ke liye, what do we have to do? We can, since it's not a constant, we're going to plug in the x coordinate of the turning point in this and find out the nature. Now here, I think it's best that we use a calculator. Let's not make life more difficult than it already is. So minus 1 upon 4, 9 raised to the power minus 3 upon 2, plus 27 upon 4, 9 raised to the power minus 5 upon 2. Okay, so ये आपने सीधा calculator में कर लें आप, and just find out the double derivative, see what you end up with, d square y upon dx square. I'm going to give you the final answer to save some time. You will get 1 upon 54. Now the value has no significance. It's the sign of the value that we're interested in. So since it's positive, that means it's a minimum. So the nature of this stationary value is that it's minimum. Okay? Okay, so let me take some questions. So is it necessary that in a quadratic equation the double derivative will never... Yeah, see, if you differentiate it once, you will get a linear equation. If you differentiate it again, you will get a constant. So yeah, that's true. In a quadratic equation, if you differentiate it twice, you will not have a variable in it. Okay? So that is it as far as stationary value and nature of stationary value is concerned. Okay? अच्छा, अब करते हैं. Now let's focus on rates of change. Okay, so sir, most insane questions. But अभी जब concept कर रहे होते हैं ना, तो फिर it's not a good idea to do most insane questions. It's important to first learn the concept, and then we can always do the difficult questions later. Sir, we only need one value to determine minimum point in an equation. We need dy by dx, and you equate that to 0. That's how you get That is how you get the stationary point. Okay, so let's look at rates of change and then we'll do some more questions as well. Okay, let's look. Yeah, definitely. There will be multiple parts of this. So now let's learn the concept of rates of change. Achha, rates of change is a very interesting concept. Okay, and it has a lot of application as well. So what will a question on rates of change look like? First, let's understand that. So what happens is, this usually happens in 3D shapes. If let's say there is a change in volume, okay, if let's say you're constantly pouring water into a container, then what happens as a result is that the height will increase, and depending on what the shape is, like for example, if it's a cone, then the radius, not of the cone, but the radius of the shape that's formed by the water will also change. Okay, so if there is a change in volume, so consequently everything that is used to calculate volume will change as well. Just like that, if you are pouring water into a conical flask, there is a change in radius, and because there is a change in radius of the water, so everything that is dependent on the radius, like for example the volume, the total surface area that is the water is in contact with, all of that will change. And what rates of change does is, rates of change basically allows us to find out the rate of change of one variable with respect to the other. Okay, so that's exactly what rates of change does. अच्छा, अब इसमें कुछ terminologies हैं that you guys need to be familiar with. Okay, there are some very important terms that you guys need to be familiar with before we start rates of change. So dy by dx. What's dy by dx? Dy by dx is basically the rate of change of y with respect to x. Okay, so that's what dy by dx, rate of change of y with respect to x. Then if you have dr upon dt, what's that? Dr upon dt is the rate of change of r, which is radius, with respect to time. It's the rate of change of radius with respect to time. अच्छा, बहुत सारे लोगों का ये misconception होता है कि if you're saying rate, we don't really have to mention with respect to time. It's understood. No, that's not true. If you're saying rate of change of radius, you have to specify what the other variable is. Similarly, if suppose you have dA upon dt. So dA upon dt का क्या मतलब है? Who can tell me? dA upon dt, look at the variable in the numerator, that's area. Look at the variable in the denominator. So dA upon dt is basically the rate of change of area with respect to time. Okay, so that's what dA upon dt is. And you can also expect something like this, dV upon dt. And what's that? Whoops. That is the rate of change of volume with respect to time. Okay, so dV upon dt is the rate of change of volume with respect to time. Okay. Now, let's solve an example question. And the approach that we are going to use to solve any rates of change of question is called the 3W approach. Okay, it's very easy. And with this approach, you can solve any rates of change question there is. Okay, so it's the 3W approach. Okay, and here it is. Here it is. So this is not a past paper question. We'll get to past paper question. Okay, shortly. First, let's do some basic questions. Now, remember this approach which we will use to solve any rates of change question. And what's this called? This is called the 3 W's approach. Okay. Now, what's the 3 W's approach? Here it is. Number one, we ask what is given. Okay. We read the question and we see what's given. All right. So let's read the question and see what's given. A circle has radius r and area a centimeter square. Okay. So the shape that we're talking about is a circle. Keep that in mind. The radius is increasing at a rate of 0.1 centimeter per second. So that means dr upon dt is equals to 0.1. Okay. So that's number one. What's given? What else is given? Let's see. That's it. There's nothing else that's given. Now, what's the other W? the other W is what is it that you want? Okay? What you want, meaning what the question wants. What you want or what the question wants. What you or the question wants. Now, what is it that the question wants? Let's see. The question is saying find the rate of increase of A. Okay, so this is what the question wants. Rate of increase of A means dA upon dt. Okay, so this is what the question wants. And then the third W, which is when do you want it? Okay, when do you want it का मतलब ये नहीं कि आपको आज चाहिए या कल चाहिए. There is a certain instant when you're supposed to work it out. And what's that? You want it when R is equals to 4. Okay, so this is the 3W approach, which we're going to use to solve any rates of change question there is. Okay? Now, start by writing down what you want or what the question wants. That is dA upon dt. Okay, now we have to set up the chain rule. Okay, we have to set up the chain rule, meaning that there are two fractions that can be multiplied, and the two fractions that we will multiply will give us dA upon dt. Now, what are the two fractions going to be? Let's see. What's the rule for finding out the two fractions? Here's how this works. The numerator of the first fraction will be equal to the numerator of what you want, so that's dA. The denominator of the second fraction will be equal to the denominator of what you want, so that means dt. Okay, I repeat. Numerator of the first fraction equal to the numerator of what you want. Denominator of the second fraction equal to the denominator of what you want. Now, what goes here and here will be same but also relevant. ठीक है, ये नहीं कि मैं यहाँ पे dv लगा दूँ. I put dv here and dv here. It has to be same, as in whatever I place here has to be here also, and it also has to be relevant, meaning it should make sense. It should be in the question. So what do you suggest I place here and here? Question for you guys. That's correct. Now, if you read the question, the only thing that makes sense is dr. So that means I can plug in dr here and I can plug in dr over here. Okay? So if I plug in dr, that's it. These are the two fractions that we're going to multiply to find out dA upon dt. Okay? Now let's see कि हमारे पास इसमें से कौन सी ऐसी चीज़ें हैं और कौन सी ऐसी चीज़ें हैं जो हमें निकालनी पड़ेंगी. Now, as far as dr upon dt is concerned, we have dr upon dt, nothing to worry about. The question is, how do we get dA upon dr? Okay, how do we get dA upon dr? Now, what shape are we talking about? We're talking about area of a circle. What's area of a circle equal to? Area of a circle is equals to pi r square. Now, what do we mean by dA upon dr? dA upon dr basically means rate of change of A with respect to r, meaning that if I have A in terms of r and if I differentiate it, I will get dA upon dr. Okay, so if I differentiate A with respect to r, I will get dA upon dr. Okay, and what's that equal to? That's equal to 2 pi r. Now, what's the value of r? The value of r that's given in the question is 4, so that means dA upon dr is equals to 2 into pi into 4, so that's equal to 8 pi. And now we have 8 pi multiplied by dr upon dt, which is 0.1. Simply multiply, so you'll have 0.8 pi or 4 upon 5 pi. Okay, so the final answer is dA upon dt is equal to 4 upon 5 pi centimeter square per second. Now, whether you write the unit or not, that's up to you, but this is the final answer. 4 upon 5 pi centimeter square per second. ठीक है? Now, let's do a past paper question. Okay, let's do a past paper question. What's the most tested topic in AdMaths? Make sure that you are very well versed with calculus, which means differentiation, integration, and all of that. Everything that comes under differentiation, integration. Okay? Let's do another question. Now let's do a past paper question. The question that I solved earlier was a question from the book. Now let's do a past paper question. Here it is. Whoops. Let's see what this says. The area of square a centimeter square has a side of length x centimeter. Given that the area is increasing at a constant rate of 0.5 centimeters square per second, find the rate of increase of x when a is equals to 9. Okay, remember the approach that I mentioned, the 3W approach. Okay, so what's the 3W approach? Let's see. So first question is, what is given? So let's see what's given. We are given the rate of change of a. Okay, so we're given the rate of change of a. Let's write that down. dA upon dt is equal to 0.5. Okay, that's what's given. So this is what is given. What is given? अच्छा, फिर number 2 पे क्या आता है? What you want. Okay, so what do you want? Let's see. Question says find the rate of increase of x. So that means we want dx upon dt. Okay, so that's what you want. So this is the first W, this is the second W, and the third W, when do you want it? Okay, or simply when. So we want it when a is equals to 9. When a is equals to 9. Okay, now let's set up the chain rule. What's the chain rule going to look like? So here's dx upon dt. Numerator of the first fraction will be equal to dx. Denominator of the second fraction is equal to dt. What goes here and here will be something that's relevant to the question, and also it's going to be the same. So what's relevant? That's dA. Okay, so as far as dA upon dt goes, we have that, nothing to worry about. But where will we get dx upon dA from? Okay, so the question is, where will I get dx upon dA from? Let's see. So what are we dealing with? We're dealing with a square that has a side length of x. Okay, so if we're dealing with a square that has a side length of x, that means area is equals to what? Area is equals to x square. Now, how will I turn a is equals to x square into dA upon dx? I can turn it into dA upon dx by simply differentiating it. So if I differentiate it, I get 2x. Achha, at this point, we want a value of x to plug in, but there's a problem. We don't have the value of x. Instead, we have the value of a. So what do we do for that? Well, here's what we can do. Remember, area is equals to what? Area of a square is equals to x square. So x square is equals to 9. That means x is equals to 3. So this is the value of x that we will plug in dA by dx. And what's that equal to? That's equal to 2 times 3, which is equal to 6. Now you might think, ye to dA upon dx hai, we want dx upon dA. Well, no problem. If dA upon dx is 6, that means dx upon dA will be 1 upon 6. So take the reciprocal of on both sides. So we have all the information that we need. 1 upon 6 multiplied by 0.5. And what's that equal to? You don't really need a calculator for this. So 1 upon 6 into half, that's equal to 1 upon 12. So 1 upon 12 is what dx upon dt is. Notice that we didn't use a calculator here. In this question or in the question above, we did not use a calculator, which means that questions like these you can expect in paper 1 of AdMaths. So you can expect questions like these in paper 1 of AdMaths. Achha, I'll take your questions now. Sir, is kinematics still part of the AdMath syllabus? Yes, beta, it is part of the AdMath syllabus. I mean, exam is literally in what? In a few days, and you're still confused about the syllabus? So it is part of the syllabus. Okay, and I always say this, you don't have to rely on me or any other teacher for the syllabus. Just go online, see the syllabus yourself. Okay, it's not a hidden document that's only shared with us. It's publicly available. Sir, AdMaths में A star के लिए कितने marks लेने होंगे, range बता दें. It depends on the threshold, but obviously the more the better. I mean, मुझे एक बात बताओ, Ayan. Who do you think starts with the aim of not getting an A star in AdMaths? I mean, I'll tell you how irrelevant these questions are. अगर मैं आपसे कहूँ कि बेटा AdMaths में A star लेने के लिए आपको 80 में से 75 marks चाहिए. Okay. What difference will that make to your preparation or to how you perform in the exam? It's not going to make a difference. Okay, how you perform in the exam depends on how well prepared you are. Okay, not what grade you're aiming for or not what is the range to get an A star. Okay, it's not like आप कहोगे कि ओ अच्छा A star लेने के लिए क्योंकि 70 मार्क्स चाहिए तो मैं एक काम करता हूँ क्योंकि मेरे 75 आ रहे हैं मैं 5 मार्क्स ऐसे ही छोड़ देता हूँ. ऐसा तो नहीं करोगे ना आप. Okay, so these questions are irrelevant कि कितने range आने चाहिए वो just the more the better, simple as that. Okay, so don't fall into this trap. ये strategy, वो strategy, ये range, फलां range. It's completely irrelevant. Just score as high as possible. That's it. Okay. When Usain Bolt is running for the 100-meter race, तो उसका क्या ऑब्जेक्टिव होता है? यू थिंक वो कैलकुलेशन कर रहा होता है कि मुझे इतनी रेंज में करना है? नो, ही जस्ट वांट्स टू रन एज फास्ट एज पॉसिबल, दैट्स इट. एंड देन व्हाटएवर टाइम कम्स आउट टू बी, वेल, टर्न्स आउट टू बी अ वर्ल्ड रिकॉर्ड. ओके, सो ये नहीं कि 9.879 का मैं टारगेट करूँ तो मैं 10 मीटर्स में इतने टाइम में, 20 इतने टाइम में, नहीं. just run as far, I mean just do as much as you can, score as high as you can, and that's it. Okay, so now let's solve this question. This is a slightly different question in the sense that you don't really have a shape over here, you simply have x and y. Okay, so I'm going to solve this. I want you guys to pay close attention, and then after that I think we can also do small change. तो हम small change भी करके ना आज इसको end करते हैं, part 1 को आज end करते हैं differentiation के. Now this question says find the x coordinate of each of the stationary points of the curve given that x is increasing at the rate of 2 units per second. Find the rate of increase of y when x is equals to 1. Okay, so I'm going to skip part 1 because it's not relevant. I'm going to jump straight to part 2. Okay, so what is it that we are given? Remember the 3W approach. What is it that we're given? What is it that you want? And when do you want it? Okay, what given, what is it that you want, and when do you want it? Okay, so what, want, when. Okay, now sir, in this class many concepts are not included in IGCSE. Is that true? Because many things I haven't done, so please tell. In this class, what do you mean in this class? But I hope you know that this is add maths, this is not math. Okay, this is add maths. It's IGCSE, but it's IGCSE add maths, it's not math. Okay, please make the habit of reading the title of the stream. Now, given that x is increasing at the rate of 2 units per second, that is what we're given, dx upon dt. I think आप लोग सिर्फ IGCSE पढ़ते हैं और कहते हैं चलो कूद जाते हैं stream में. Okay, it is IGCSE, but it's IGCSE add maths. Just like there's IGCSE physics, just like there's IGCSE chemistry, there's IGCSE add maths as well. Not every IGCSE subject is math. This is not 0580, this is 0606. Okay, this is not 0580, this is 0606. Anyway, so this is what we're given. Now, what is it that you want? You want the rate of increase of y. So that means we want dy upon dt. Okay. And when do you want it? You want it when x is equals to 1. नहीं मैं नाराज़ नहीं हुआ. It's just that you guys don't read the title. And that is a habit, and that leads to not reading the question and not answering it correctly. Okay, so just not reading the instructions is a bad habit, and it can have consequences. Anyway, so we want dy upon dt, let's focus on that. Now the question is, how will we get dy upon dt? We need to multiply two fractions to get dy upon dt. Now the numerator of the first fraction will be equal to the numerator of what we want. Denominator of the second fraction will be equal to the denominator of what we want. What goes here and here will be common and relevant to the question. So what is it that's checking both the boxes? That's dx. Okay, dx is checking both the boxes. Now we want dy by dx, which means we'll have to use quotient rule to differentiate it. Y is equals to 2x upon x squared plus 9. And what's the value of x that we're going to plug in? We're going to plug in 1. So I hope you guys know कि हम ये calculator में directly भी कर सकते हैं, and we will do it only to check our answer. Okay, so don't ask me that if I don't show my working, just use the calculator, will I get marks? You won't obviously get marks. So v is equals to x squared plus 9, which means v prime is equals to 2x. अच्छा, by the way, अगर आपको याद हो, हमने exactly यही question का first part already solve किया. Okay, so what's dy by dx equal to? Dy by dx is equal to vu prime, that means 2 times x squared plus 9 minus uv prime, that means minus 4x squared upon v square, which means x squared plus 9, the whole thing square. Now we have the value of x which we have to plug in, that's equal to 1. So let's plug in 1. So 2 into 1 square plus 9 means 10, minus 4 into 1, so that's 4, upon 1 square, which is 1, plus 9, that's 10. So that's 100. So this is dy by dx. Okay, now let's solve this. 2 times 10 minus 4 divided by 100. So we're looking at 0.16. So dy by dx is equals to 0.16. Now we have all the information. Dy by dx is 0.16. Multiply that by dx upon dt, which is equal to what? Which is equal to 2. And let's solve. And we have 0.32. And that's the final answer. Achha, sir, if I watch A-level math trick, am I able to do add math trick? You can watch A-level math trick, but it's not gonna, it won't be enough. Okay, it won't be enough. Sir, can we use differentiation to find minimum points while sketching quadratic? No, I don't recommend that. You're not gonna get any extra marks. You'll end up wasting a lot of time. Sir, do a video about transformations and mathematically similar questions. I have done mathematically similar. I've already made a detailed video on similar triangles and similar shapes. You can check it out. But transformation, inshallah, I'm streaming very soon. Okay, as you can expect a stream on transformation very soon. Anyway, so that was rates of change. Okay, so that was rates of change. Now let's talk about small change. Okay, so just a minute. Let's discuss small change. अच्छा, small change भी बहुत एक simple सा concept है. It's basically a formula that you need to know. Okay, and with the help of the formula, you can solve any small change related questions. It's something that's not tested very often, but it's tested nonetheless. Here it is. So we're just going to straight away solve a past paper question, and we're going to learn the concept through that only. So what are your thoughts about the most difficult topic in advanced? I think the most difficult topics in advanced, like, see, there are some topics that is okay if you struggle in. So there are some topics that it's totally not okay to struggle in. Like, for example, it's not okay to struggle in circular measure, binomial, APGP, logs, coordinate geometry, even differentiation integration. It's not okay if those aren't your strong topics. But it is okay if you find yourself struggling with functions and occasionally with trigonometry. So these are the two topics I think that are most difficult. So if you struggle in these two topics, that's acceptable. Okay, but it shouldn't remain that way. That doesn't mean that you can just forget about those topics and not make an effort to, better your understanding. You should always do that. But it's okay to find these two topics hard. That's what I would say. Anyway, so let's solve this question. Let's see what it says. So it says variables x and y are connected by the equation so and so. Find the approximate increase. Achha, how do I know that this is a small change question? Whenever the question says approximate increase, that means it's a question related to small change. So how do I know it's small change? Look for terms like approximate increase or approximate change. Look for these terms. Okay. Now, what's the formula? Remember, it's just the formula that you need to solve any small change question. And that is small change in y over small change in x is approximately equal to dy upon dx. That's it. This is the formula that you need to solve any small change question there is. Okay. Now, what do we notice? We notice that x from 2 is going to 2.05. So what's the small change in x? The small change in x is 0.05. Okay? Achha. What do we want? We want the approximate increase in y. इसको हम small change भी बोलते हैं, इसको हम approximate change भी बोलते हैं. ठीक है? So this is what we want. Okay, we already have the small change in x, but the question is, where do we get dy by dx from? Okay, so where do we get dy by dx from? So we're given the equation of the curve, and here it is, x cubed plus x squared. What we're going to do is we're going to differentiate it. So as I differentiate it, this is what happens. 3x squared plus 2x. Now we need a value of x To plug in dy by dx, the value we're given is 2. So let's plug in 2. 3 times 2 square is, well, we'll work it out in a minute. So 2 square is 4, 4 times 3 is 12, 12 plus 4, what's that equal to? That's equal to 16. Let's just double check. 2 square is 4, 4 times 3 is 12, 12 plus 4 is 16. So that means we have dy by dx as well, and that's equal to 16. Now when we cross multiply, because there's an approximately equal to sign, so that is why the small change in y that we get will be approximately equal to, not exactly equal to, 16 times 0.5, and what's that equal to? That's equal to 8. And there you go. That's the answer. Take a good look at it. Achha, wait a minute. I just realized it's not 0.05. It's actually it's not 0.5. It's actually 0.05. Okay. So the small change in y is in fact equal to 0.05 times 16, which is going to be 0.8. We always take the initial value. Okay, so in dy by dx, always plug in the initial value. So you can make a note of that if you want. To find dy by dx, plug in the initial value. To find dy by dx, plug in the initial value of x. Okay. So is there any logic behind using the initial value? So yes, there is. Since it's approximate change, what we are doing over here is हम ये कह रहे हैं कि वो जो क्योंकि x में ज़्यादा change नहीं आया, so this is the logic behind. So suppose that here's x, which is equal to 2, and suppose here is the other value of x, which is 2.05. Okay, so this is the logic behind. If you get it, that's great. If not, then don't waste your time right now, at least, to memorize the logic. Just understand the concept. Now, when we plug in dy by dx, when we plug in 2 and dy by dx, technically what do we get? We get the gradient of tangent. Okay, so we get the gradient of tangent. अब हम ये कह रहे हैं, what we are saying is this. When we say approximate change in y over approximate change in x is equals to dy by dx, so what we are saying is that if you were to draw a straight line from here to here, okay, if let's say you were supposed to draw a straight line from here to here, तो जो इसका change in y over change in x होगा, वही आपके dy by dx का change in y over change in x होगा. Okay, so if let's say you take the small change in y over small change in x, so the gradient of the line in red is approximately equal to the gradient of the line in blue. Okay, so that is why we use this formula. The small change in y over small change in x is approximately equal to dy upon dx. That's the logic here. Okay, sir, can we find the value of y from small? See, we can do that. You can find out the value of y using both the values of x, but that will give you the exact change. You're not supposed to find out the exact change, you're supposed to find out the approximate change. Okay, and for approximate change, this is the formula that we use. Okay, if let's say you wanted to find out the exact change, obviously we're going to plug in x equals to 2, we're going to find out the value of y, then we're going to plug in 2.05, we're going to find out the other value of y, and the answer that we will get will subtract the 2 and we will have the exact change. Okay, so but here we are supposed to, so basically we're seeing the benefits of differentiation. So one benefit of differentiation we saw during rates of change. Here is another benefit of rates of change, and that is differentiation, and that is you can use it to find out approximate change in one variable if you're given the approximate change in the other variable. Okay, so here's a past paper question. Now majority of the past paper questions of small change will be in terms of h or in terms of a certain unknown. Okay, so we're going to solve this question, and then after this we will stop. In the next class, inshallah, we will do these questions. This practical maximum and minimum problems. So we are Thank God we're done with this, we're done with this, we're done with this, and we're going to be done with this. In the next class, we're going to have a detailed stream on this. Okay, so this will come in part 3. And in this stream, you will have all these concepts covered here. Okay. Is log still part of the 0580? What do you mean still? It was never part of the 0580 syllabus, and it's not part of the syllabus right now also. सर 2 आवर की एटलीस्ट स्ट्रीम करवाएं बेटा एग्ज़ाम्स करीब आने दो फिर हम करेंगे 2-2 3-3 घंटे की ठीक है अभी एग्ज़ाम्स करीब नहीं है इसलिए देयर इज़ नो पॉइंट इन स्ट्रीमिंग फॉर 2-3 आवर्स वंस एग्ज़ाम्स आर क्लोज दैट इज़ व्हेन वी विल डू लेंथी स्ट्रीम्स Okay, so here's a past paper question which we're going to solve. Two variables x and y are such that so and so, find an expression for dy by dx. So before you differentiate, make sure that you write it in a way so that it's easy for you to differentiate. So that is 5 times x minus 9 raised to the power minus 1 upon 2. Okay. Now we can differentiate it. So dy by dx is equal to 5 into minus 1 upon 2. That's going to be minus 5 upon 2. X minus 9 raised to the power minus 1 upon 2 minus 1. So that's going to be minus 3 upon 2. Okay. Also, when we're doing just past paper questions, that is when we'll do a lengthy stream. Okay. When we're learning concepts, it's best to learn concepts in small chunks rather than learning everything at once. Okay. That's what I prefer. So we have dy by dx. Since the question doesn't say that it wants it in a certain form, we're just going to leave it as it is. Okay. Hence, find the approximate change in y as x increases from 13 to 13 plus h. So let's write down the formula. Small change in y over small change in x is approximately equal to dy by dx. Okay, it's approximately equal to dy by dx. Now, what's the small change in x? Let's see. So x was 13. Now it has gone to 13 plus h. So that means the small change in x is basically h. Now, what's the small change in y? That's what we're supposed to find out. And the question is, where do we get dy by dx from? Well, this is what dy by dx is. Dy by dx is equals to minus 5 upon 2 into 13 minus 9 raised to the power minus 3 upon 2. Now, let's try and not use a calculator over here. So, minus 5 upon 2, 13 minus 9 is 4. 4 raised to the power minus 3 upon 2. So, minus 5 upon 2 into 4 raised to the power 3 upon 2. Okay, I'm trying not to use a calculator. It's very easy to work this out in a calculator, but questions like these you can expect in paper 1. So minus 5 upon 2 times. Now what's 4 cubed? That's 64. What's the square root of 64? That's 8. So that means we have minus 5 upon 16. So that's our dy by dx. Let's replace this with minus 5 upon 16 and let's cross multiply. And what do we have? We have the small change in y, which is approximately equal to minus 5 upon 16h. Okay, surprisingly, my iPad ki battery bhi dead ho gayi hai. Okay, that was going to be the last question anyway. The answer is minus 5 upon 16h. And let's see if that's the correct answer. Yeah, that is the correct answer. Part 3, inshallah, this week. Okay, so this week only, inshallah, I will do part 3. मोस्ट लाइकली या तो फ्राइडे को होगा या हो सकता है कल क्या है कल थर्सडे है ना सो मे बी इवन it's possible that it's tomorrow. Okay, I'll announce and I'll let you guys know when part 3 is coming out. So anyway, kahan the hum? Let's complete this. Yeah, so minus 5 upon 16 h is the answer. So let's keep it till here only. And we will inshallah connect in the next class, in the next stream where we will do part 3. Okay, so I'll announce on my Instagram, I'll announce on YouTube, you guys can find out. Okay, and once again, you guys can download all the notes from the website. And the past paper session for maths is starting from the first week of April. If you guys are interested, you can also register directly from the website. So how to do the cylinder questions on differentiation? I will do that when we're doing practical applications. Okay, when we're doing practical applications of differentiation, that is when I'll cover it. ठीक है, आज के लिए काफ़ी है. I'll see you guys in the next stream. Take care. Jate jate. If you haven't liked the stream, please do that. I'll appreciate it. And also do subscribe to the channel while you're at it. And yeah, that's it for today. Take care.